You know, usually when we talk about securing a building or securing a network, there's this expectation of a structural logic.
Yeah, like a clear perimeter.
Exactly. Engineering. You put a heavy steel vault in a bank, you require a multi-digit combination, and the security guard basically just points at the thick metal door and says, there it is. Nobody is getting through that.
Right. It's clean. It's predictable.
Yeah. And we've built our entire mental model of enterprise security around that exact concept of a perimeter.
We really have. It's a comforting model for a lot of people. I mean, we trust boundaries to be visible and binary.
Right.
You're either outside the vault, untrusted, or you have the combination and you're inside.
But then you step into the reality of enterprise infrastructure today. And I want to welcome you to today's deep dive because we're looking at a reality where that steel vault door is completely irrelevant.
Yeah, totally useless.
Attackers aren't picking the locks anymore. They aren't even bothering to steal the combinations, really.
No, they're not.
They're just walking right past the vault door as if it doesn't even exist. And the threat landscape is terrifyingly silent because of it.
It is.
So our mission today is to unpack a sudden, really severe wave of zero-day and unauthenticated exploits targeting the most critical layers of enterprise infrastructure.
And that word right there, unauthenticated, that's what we really need to focus on here.
Right.
We're looking at a fundamental breakdown in how systems actually validate who is asking them to do things.
Exactly. And we've got 3 distinct sources on the table today detailing 3 separate massive compromises.
Big ones, yeah.
We're looking at a severe vulnerability in the Metabase data visualization platform. We're analyzing a deep compromise of N-Aval's N-Central RMM. And finally, we're tracking widespread automated attacks against the Progress Kemp LoadMaster.
All active right now, by the way.
Yes, active in the wild right now, meaning as we speak, threat actors are leveraging these exact flaws to operate inside corporate environments.
If we pull back and look at the telemetry across these 3 distinct incidents, a very clear, very disturbing pattern emerges for you to see.
Which is?
The traditional perimeter, the login screen itself, is dead.
Wow.
It really is. Threat actors are bypassing identity entirely to take just unrestricted control of networks.
Okay, so let's get right into the mechanics of this, starting with the Metabase flaw.
Sure.
For context, for those who might not deal with it every day, Metabase is deeply embedded in the data pipeline of thousands of organizations. It essentially sits on top of the most sensitive databases a company has, just so that business intelligence teams can run analytics.
Right, and by design, it requires highly privileged access.
Right, it needs to see everything.
Exactly. It has the keys to the kingdom because its entire function is to query and visualize the organization's core data storage.
Which makes this zero-day an absolute nightmare.
Oh, yeah.
It carries a maximum CVSS score of 10.0. It affects versions 1.58 and above. And the core mechanism is an unauthenticated remote SQL injection into the application's own database.
Just brutal.
Yeah, instantly granting full administrator access. Now, mathematically, a 10.0 is rare.
It's extremely rare.
Usually there's some mitigating factor, right?
Right.
Like a specific configuration required or some level of user interaction.
Right. Somebody has to click a link or something.
Exactly. But here, there's zero friction.
And the lack of friction is what makes this so severe. Think about how modern web applications are structured.
Okay.
You have the pre-authentication endpoints.
So the pages you can hit before you log in.
Right. And the vulnerability here existed in the API session reset password endpoint.
Wow. The one endpoint that absolutely has to be exposed to the public internet by design.
Exactly. Because the application needs a way to help users who forgot their credentials.
Of course.
But the way Metabase was parsing the input on that specific API endpoint was just fundamentally flawed. It failed to sanitize the JSON payload it was receiving.
Okay, so let's go back to that bank vault analogy to visualize what's actually happening at the code level here.
I like this analogy.
Yeah, so this SQL injection, it's like walking into the bank lobby, ignoring the giant vault entirely, and just whispering a very specific nonsensical string of words to the teller at the front desk.
Right, just total gibberish to a normal person.
Exactly. And upon hearing this specific syntax, the teller's programming just breaks.
Yep.
They become completely hypnotized, reach under the desk, and hand you the master keys to the entire building.
That captures the logic flaw perfectly.
You didn't steal a code. You exploited the way the teller processes language.
Yeah, the magic words are basically database commands wrapped inside a request that the application thinks is just a routine password reset token.
So the system is just incredibly gullible.
Very gullible. The API parser gets confused, it drops the context of the password reset, and it just executes the database command directly against the backend.
Wow.
In this case, the command modifies the application's database to elevate the attacker session to a full administrator.
And once that elevation happens, the scope of the damage is just immediate, isn't it?
Oh, absolutely. I mean, an attacker with admin access to the BI tool, they can change application configurations.
Right.
But more critically, they can extract the stored plaintext credentials for every single connected database.
So they own the entire data pipeline.
They own it all. They aren't just looking at your pretty charts. They are pulling the raw connections to your Snowflake, your AWS RDS, your Postgres instances.
Everything.
Everything. They can read any data accessible through those service accounts and export it right out the door.
And we have a real-world victim detailed in the sources that illustrates this perfectly.
We do, yeah. Framework.
Right, the PC Maker, Framework. They're known for their highly customizable laptops. Yeah. And they disclosed that they were compromised through this exact Metabase vulnerability.
Right.
According to Engadget's reporting, the attackers gained access to a massive trove of customer PII. We're talking names, login IPs, physical addresses, phone numbers, and emails.
It's a huge haul for an attacker. Now, Framework noted that no order or payment information was compromised, which is good.
Right.
But we have to look the secondary market for this kind of data. Clean, correlated PII.
Especially tied to a specific tech-centric demographic like Framework's customer base.
Exactly. That is incredibly variable. Threat actors use it to craft highly targeted spear phishing campaigns, or they attempt credential stuffing on other platforms.
So the blast radius of a compromised BI tool extends far beyond the initial breach.
Way beyond it, yeah.
So to mitigate this, before the official patches were widely deployed, Metabase advised users to completely block that API password reset endpoint at the network level.
Which is a brutal but, completely necessary workaround.
Right, you're essentially breaking a core feature of the application.
Just to stop the bleeding.
Yeah.
Yeah, while you wait for the engineering team to rewrite the validation logic.
Now, Metabase's CEO, Samir El-Sakran, also released specific indicators of compromise. And he made a point to emphasize that if administrators find these specific alphanumeric patterns in their application logs or their ingress logs, quote, it is likely that your instance has been compromised.
Yeah, and that statement really highlights a massive gap in modern security operations.
How so?
Well, a 10.0 vulnerability means the front door is completely missing, right?
Right.
But your ingress logs, those are basically the security cameras recording the empty doorway.
Oh, I see.
The problem is log ingestion noise. Most organizations are piping terabytes of data into their SIEMs daily.
So it's like a needle in a haystack.
Worse. If your SOC isn't actively tuning their detection rules to alert on these specific SQL injection payloads hitting pre-auth endpoints, you could be compromised right now, and the evidence is just sitting buried in an unread log file.
That's terrifying.
Yeah.
And that transition from data theft to absolute infrastructure control actually brings us to our second source.
Yes.
Because while the Metabase attackers wanted to siphon data out of the pipeline, the attackers targeting N-able's N-central platform had a completely different objective.
Totally different gameplay.
They went after the RMM to establish total dominion over the managed environments.
Right. We're moving from the application layer to the management plane here.
Okay.
And when you compromise the management plane, you basically inherit trust over every single endpoint that platform communicates with.
So let's lay out the timeline, because I think it's crucial for you to hear.
Yeah, the timeline matters.
On July 31st, 2026, N-able detects unusual activity in a customer environment. This investigation uncovers a zero-day flaw in the N-central server, tracked as CVE 2026-18577.
Right.
It's a CVSS 8.2, impacting versions prior to 2026.3.1.7.
Yeah.
And just like Metabase, it allows for authentication bypass and account takeover.
But the detail that really demands attention here is the lineage of this vulnerability.
Okay, what do you mean?
The sources explicitly state that CVE 2026-18577 is an incomplete fix for an older vulnerability.
Wait.
Yeah, CVE 2026-18556.
Okay, wait, I have to stop and ask about this.
Go for it.
Because Enable released Hotfix 2 with some incredibly urgent messaging. They told their customers, quote, "This is not a duplicate. Hotfix 2 is required even if you already applied the earlier hotfix."
Right.
If they already issued a patch for this exact mechanism, how are attackers walking right back in? Are we just patching the symptoms and leaving the underlying architecture fundamentally broken?
That is exactly what's happening. And that's the core problem with massive legacy code bases. It happens way more often than vendors like to admit.
So it is just whack-a-mole.
It is. I mean, enterprise software is incredibly complex. It's often pieced together with different API gateways, legacy validation libraries, newly bolted on features.
Right.
When a vendor discovers an authentication bypass being exploited in the wild, the immediate reaction is to just block the specific JSON payload or the exact HTTP request sequence the attacker used.
Okay, so they close the specific pathway,
Yep.
but they don't fix the insecure object reference in the back end.
You nailed it. They put a filter on the front door.
Unbelievable.
But highly capable threat actors will immediately reverse engineer the patch.
They'll just look at what changed.
Exactly. They look at the new hotfix, analyze what was blocked, and realize, oh, the underlying validation logic is still deeply flawed.
Wow.
They just craft a slightly different request, maybe hitting a different API endpoint that routes to the same vulnerable backend function, and they bypass the patch entirely.
And that's why Hotfix 2 was pushed with such urgency, requiring those additional hardening measures.
Yeah. The attackers adapted to the first patch in real time.
Well, both the original flaw and the bypass have been added to CISA's known exploited vulnerabilities catalog.
Rightfully so.
And the tech chain they used once they bypassed authentication is just incredibly sophisticated. They didn't just run ransomware, right?
No, they used N-Central's built-in take control feature.
Which is wild to me.
They weaponized the legitimate administrative tools. This is a classic living off the land technique.
So they didn't even need to bring their own tools.
Why would you? I mean, why deploy noisy malware when the RMM already has an agent installed on every machine with system-level privileges?
Exactly. So they pivot through the managed systems, and then they deploy a Cloudflare tunnel.
Yes.
Now, you've got to explain the mechanics of a Cloudflare tunnel in this context, because this seems to be the absolute linchpin of their entire persistence strategy.
It is. So to understand why this is so devastating, think about how traditional network egress works.
Okay.
Firewalls are heavily restrictive about traffic coming in, right?
Sure. Okay.
But they are generally pretty permissive about traffic going out, especially over standard web ports like 443.
Because employees need to browse the web.
Exactly.
Yeah.
So a Cloudflare tunnel is a totally legitimate service designed to securely expose internal services to the internet without opening inbound firewall ports.
Right, because the connection is initiated from the inside out.
Precisely. The attacker runs a lightweight daemon on the compromised endpoint. That daemon reaches out to Cloudflare's edge network and establishes a persistent, encrypted outbound connection.
Okay, I follow.
Once that tunnel is established, the attacker can route traffic back through Cloudflare directly into the victim's network.
Wow. So even if the defenders realize the N-Central server is compromised, even if they physically pull the plug on the RMM server, the attackers don't lose access.
They wouldn't even notice. The RMM was just the delivery mechanism.
That is terrifying.
By deploying Cloudflare tunnels on the individual managed devices, they created parallel, invisible infrastructure.
Because Cloudflare's everywhere.
Right. And because it's a ubiquitous, legitimate service, the telemetry just looks like normal, encrypted web traffic to the SOC.
So it completely bypasses standard EDR behavioral alerts.
Completely bypasses them.
It's surgical. I mean, you think you've eradicated the threat by patching the server, but they've already woven themselves into the fabric of the endpoints.
Deeply embedded.
So we've gone from targeted data theft in Metabase to stealthy embedded persistence in Enable. But our final source shows what happens when threat actors drop the stealth entirely and just start indiscriminately hammering the edge of the internet.
Yeah, if the Enable compromise was a scalpel, this next one is just a sledgehammer. We're looking at automated exploitation here.
CISA recently mandated that federal civilian executive branch agencies patch a critical flaw in the Progress Kemp LoadMaster by August 10th, 2026. This is tracked as CVE 2026-80037, and it carries a massive CVSS score of 9.6.
So let's talk about where a LoadMaster sits architecturally, because it matters.
Okay.
A load balancer is the absolute edge of your perimeter.
Right.
Its job is to ingest all incoming internet traffic, terminate the TLS encryption, parse the requests, and then distribute that traffic across your internal server farms.
So it's basically the traffic cop.
It is the central nervous system for your inbound routing.
Which means every single malicious packet an attacker sends has to be processed by this device.
It processes everything. And the vulnerability here is command injection caused by unsanitized input across multiple API endpoints on the appliance itself.
And once again, no valid credentials needed.
None at all.
An unauthenticated attacker can just send a maliciously crafted HTTP request to the load balancer. And because the appliance doesn't properly sanitize the string before passing it to the underlying operating system,
it executes arbitrary code.
Boom!
Boom. This is the real danger of monolithic edge devices. I mean, they are incredibly complex Linux machines doing heavy string manipulation to route traffic.
Right.
When you find a command injection flaw here, you aren't just compromising a web server.
What are you getting?
You're getting root access to the device that holds the SSL certificates for the entire enterprise.
Oh, wow. And the scale of the active exploitation is staggering. We have telemetry data captured by Kemp.
Yeah, the numbers are wild.
In just a 41-day window, they observed 792 distinct exploitation attempts.
Just automated hammering.
And these originated from 65 unique IP addresses distributed across 18 different countries.
That data tells a very specific story about the threat actor's methodology.
How's this story?
This isn't a targeted campaign against a specific sector. This is indiscriminate automated scanning.
So they're just casting a huge net.
A massive net. Threat actors have built scripts that are systematically scanning the entire IPv4 address space.
Right.
They're looking for the specific HTTP response headers that fingerprint a progress Kemp LoadMaster. And the moment they get a match, they automatically fire the command injection payload.
But there is an observation in the sources from the cybersecurity firm Entire that really caught my eye.
Oh, the success rate thing.
Yeah. They tracked these active exploitation efforts, but they reported that the attempts were, quote, largely unsuccessful.
Right.
So I have to ask, if the payloads are failing, why is CISA treating this with such extreme urgency? Why the federal mandate to patch immediately if the bots are largely missing their targets?
It's a great question, but in threat intelligence, you have to separate the current success rate from the capability and the intent.
Okay, explain that.
Yes, Entire observed unsuccessful attempts, but those automated bots might be hitting honeypots or systems that were aggressively patched on day zero.
So they're just firing blanks at walls.
Exactly. Sometimes the payloads are slightly misconfigured for specific firmware versions, causing the exploit to crash the service instead of returning a shell.
But the infrastructure to scan the entire internet is actively running.
And that is the critical takeaway.
Right.
The internet is being actively hunted by highly resourced actors. Just because a bot failed to compromise a dozen patched systems doesn't mean the risk is mitigated.
Because eventually they'll find an unpatched one.
Exactly. When that automated script finally hits an unpatched, vulnerable LoadMaster, the consequences are immediate and catastrophic.
Because, like we said, if you control the load balancer, you control the routing table.
You control the routing table, you possess the TLS keys to decrypt traffic.
Wow.
You can seamlessly redirect internal employee portals to credential harvesting clones.
Man-in-the-middle stuff.
Completely. Or you can use the appliance as a pivot point to launch attacks deep into the internal network, completely bypassing the external firewall.
Because the load balancer is the trusted ingress point.
Yes. You cannot leave a 9.6 severity flaw unpatched on an edge device when the telemetry proves the exploitation infrastructure is running globally.
It's just a ticking time bomb at that point.
It really is.
Well, taking a step back and looking at the architecture we've dissected today for you, the through line is just undeniable.
Very clear pattern.
We started with an unauthenticated SQL injection in a core data visualization tool, Metabase, allowing attackers to just dump back-end database credentials.
Then we moved to the enable RMM, where attackers bypassed authentication to weaponize the management plane itself.
Right, deploying those Cloudflare tunnels to establish invisible, persistent outbound connections that entirely evade traditional network telemetry.
And we finished at the absolute edge of the network with the Progress Kemp LoadMaster, where automated bots are indiscriminately firing command injection payloads to take over the appliance's routing enterprise traffic.
The erosion of trust boundaries is really the defining security crisis of this decade. I mean, we spent 20 years building security models around identity validation.
MFA, complex passwords, conditional access.
All of it. But in all three of these major incidents, identity was completely irrelevant.
Completely irrelevant. Threat actors are capitalizing on the complexity of modern API integrations and monolithic code bases to just turn minor input validation errors into systemic, unauthenticated compromises.
They aren't trying to break the locks anymore. They've realized the walls around the locks are structurally unsound.
Yeah, they're just walking through the drywall.
Exactly. Which leaves us with a final thought to examine. Look at the specific targets in these three incidents.
Okay.
They targeted the BI tool to access the data pipeline. They targeted the RMM to control the endpoints.
Yeah.
And they targeted the load balancer to manipulate the traffic.
They're specifically compromising the platforms that have the highest level of inherent trust.
Exactly. As threat actors continue to shift their focus away from individual user endpoints and directly toward the management planes, the APIs, and the edge appliances, we have to confront a deeply uncomfortable reality about how we design enterprise architecture.
That's a tough pill to swallow.
It is. Are the incredibly complex, highly privileged infrastructure tools we buy to manage, scale, and secure our networks actually becoming the single greatest vulnerabilities we possess?
It's a real paradox.
We build these massive interconnected systems to give us visibility and control, but when the underlying code fails to sanitize a single line of text, that entire architecture is weaponized against us in milliseconds.